Welcome to Ocean 201, Introduction to Plate Boundaries. Today we are going to start to talk about plate tectonics, and that'll be the focus over the next several lectures. And this follows on from what you've learned about seafloor spreading already, and it has to do with the breakup of the solid lithosphere into plates that can move. And this is what gives us many of the features that we can see on the Earth's surface. So ocean ridges, trenches, mountain ranges, all of that is due to plate tectonics. I apologize if you see a random cattail appearing. Well, one of my cats is not leaving me alone today. Okay, so our topic learning objectives for this module are to describe the movement of plates and continents, to characterize the differences between different divergent boundaries, convergent margins, and transform margins, and also then to explain how mantle plumes and hotspots lead to island and atoll formation. So the theory of plate tectonics was formulated by Wilson in 1965, and it incorporates concepts from continental drift and seafloor spreading. Basically, the seafloor is broken up into rigid slabs called lithospheric plates, and these float on top of the asthenosphere. And these plates can flow freely, but they interact where they meet. And so we'll talk more about their interactions over the next few videos, but today we're just going to go over the basics. And so, for example, you have all these different interactions between plates. So if you look at this map where you see the blue lines with the triangles, those are convergent boundaries, meaning plates are coming together. So for example, here, the Nazca plate is coming towards the South American plate, and it's actually being subducted underneath the South American plate. And so that's what the triangle direction means on these boundaries. It indicates which plate is going underneath. So the triangles are on the side of the plate that is riding up on top of the other plate. Now we also have divergent boundaries in red. These are where two plates are moving apart. So the Pacific plate, for instance, is moving north and west, while the Nazca plate is moving away from it, and the Antarctic plate is moving away from it. And that's where we have new seafloor formed, and those are called divergent boundaries. And then transform fault boundaries. These occur all along divergent boundaries, and then also in some areas by themselves, and that's where two plates are slipping next to each other. They're sliding next to each other. We're not losing or creating any new plate, but they can cause serious faults. So the San Andreas fault is an example of a transform fault. And so this all brings us back to the breakup of Pangaea, which was a supercontinent that existed between 335 million years ago and 200 million years ago. Pangaea, so this was the latest supercontinent. There have been supercontinents that have formed and broken up. I think the current estimate is about 10 times in the history of the Earth. Just our most recent one is what we're focused on. And Pangaea started to break up about 200 million years ago. It was focused in the tropics, and as you had plates moving apart and new seafloor spreading occurring and new ocean basins occurring, these continents moved apart, and we started to see the formation of the continents that we know today. So around 135 million years ago, Laurasia broke off, so that's a combination of North America and Eurasia, and we had that broke off from Gondwanaland, so South America and Africa. At that time, India has broken off from Antarctica and Australia. Then about 65 million years ago, India is moving up towards Eurasia. Antarctica and Australia are starting to separate. You have the Atlantic forming, the South Atlantic is starting to grow. And then finally, in present day, we've had the Atlantic is fully formed. North and South America are just barely joined. India has rammed into Asia, forming the Himalayas, and Australia and Antarctica are fully separated. And these processes are still going on. So for example, the Rift Valley in Africa, this is a video or a picture from there. That's essentially where the African plate is starting to break up, and we are seeing what will eventually turn into a new ocean basin. The Red Sea is another example of the formation of a new ocean basin. So our main lithospheric plates, there are 7 of them: the Pacific Plate, North American Plate, Antarctic Plate, the South American Plate, the Africa Plate, Eurasian Plate, Indo-Australian, and I may have missed one there or just been distracted by my cat again. Sorry about that. So let's see, there's also a lot of minor plates. So the Juan de Fuca Plate, Nazca Plate, Cocos Plate, these are all important for America. And again, these are, you can see where the plates are moving apart or subducting. These boundaries are what we're really going to focus on, which are where 2 plates interact and where you have new ocean floor spreading at mid-ocean ridges. You have trenches that form on the subducting side of plate convergence. So we'll talk more about trench formation. And this is also what gives rise to earthquakes. So this is a map of earthquakes from 1900 to 2020. The size of the symbol represents the overall strength of the earthquake, so it's the amount of work done basically by the earthquake. And then the color is the depth. And so what you notice here are in the mid-ocean ridges where they're spreading, we see lots of red dots, very shallow earthquakes, whereas the deepest earthquakes, the blues down, going down to 700 kilometers or so, are at these convergent boundaries where one plate is subducting under another, and as that plate subducts down, you get formation of earthquakes very deep down in the Earth's crust. So that's what we can take away from that. But if we go back and forth, you can really see the coherence of where we see earthquakes relative to plate boundaries. You do see a few spots where you have earthquakes away from the edges of plates, in the middle of plates. So for example, where we are in Hawaii, you see some earthquakes there, and these form at what are thought to be ocean hotspots. So we do get some earthquakes away from the edges of plates, but not too many. Okay, so the 3 types of plate boundaries that we're going to talk about: divergent plate boundaries. These are ocean ridges where you have seafloor spreading and the creation of new oceanic plate. Convergent boundaries, where you have 2 plates coming together, and this can lead to subduction zones where the denser plate subducts, and you have destruction of old oceanic plates. And then conservative boundaries, so transform faults where the plates slide past each other, but you don't have creation or destruction of any plates. And overall, the Earth's size is fixed, so the destruction of plate must be balanced by new construction. So any destruction of plates through subduction in convergent boundaries is balanced by formation of new plates in divergent boundaries. That is all we have for today. We will pick up with the discussion of the specifics of the plate boundaries in the next video.